All right, so here's an example of a type of one-factor medication question you could come across in your Unit 2 exam and in your final exams, and as a nurse, or all the exams you'll be taking throughout the program, and even medication exams you'll take when you apply for jobs, believe it or not. So I'm going to put my recording on pause, and for those watching the recording, you should pause the recording here so you can attempt to do it before I do it and you see the answer. So I'm going to give everybody some time I'll give you a couple minutes of. All right, so this is a classic one factor. So the first thing we look for is that doctor's order, and that is our given. The doctor, and it says orders, 80 milliequivalents. So I start with 80 milliequivalents. I like to put it over 1, you don't have to. And what am I solving for? What's my wanted? It just says administer. Well, what am I going to administer? Well, it only comes in a liquid. And this is the only other thing in my problem. So I'm administering milliliters. I'm going to put that over 1. So I know that milliliters has to be in my numerator. So I've already used the 80 milliequivalents. So how do I get rid of milliequivalents and get milliliters? Well, I look to my problem and I'm going to put 20 milliequivalents in 5 milliliters. Pay attention when you're transcribing because I see errors with people transcribing information. So I've used that. And now I have milliliters, and that's exactly what I need. So now I just solve. So 80 times 5 is 400, and 20 times 1 is 20. And when I divide 20 into 400, it is 20 milliliters. And that is it. That's all I'm putting on my answer line, 20 milliliters. Very good. So here's another example of a one factor. So I'm going to encourage you to pause the recording if you're watching it and attempt to do it. So yes, you got to make sure if you put the wrong unit of measure, your answer is wrong, no matter what. All right. Now this one you're thinking, I don't even need to do dimensional analysis to figure this out. But on my exams and any exam you take in the nursing program or probably anywhere at this point, you have to show your work. So we're going to go through the same long drawn out process. Where is my doctor's order? I start with the given and I look for the word order or prescribed, and he ordered 800 milligrams. And he's asking, what am I going to administer? Well, it's only available in what? Tablets. So that's what I have to administer. So I'm solving for tablets, and I need to make that my numerator. So the order is 800 milligrams and available is 400 milligrams per tablet. Cross off my milligrams, have my tablet. Now I'm ready to solve. 800 times 1 or nothing is 800. 400 times 1 is 400. And that will give me 2 tabs or tablets, not 2 milligrams. If you write 2 milligrams, you get that answer wrong. That's the wrong unit of measure, because if you wrote, I want you to think about it this way. If you write 2 milligrams, you already didn't follow the doctor's order. He ordered 800 milligrams, right? So make sure your unit of measure is correct. And this answer is 2 tabs. Beautiful. All right. Try this problem. If you're watching the video, pause it here. All right, let's do it together. Don't forget the rounding rules. So again, I'm going through the same process. I'm looking for that given, which is my order. So I'm reading my question. A medication bottle is labeled 0.8 milligrams per 2 ml. So I got something there. And prescribed is 4.5 milligrams. That's my order. And then what am I going to administer? So I start with my given, which is my order, 4.5 milligrams. Beautiful. And I have to administer something. Well, it only comes in a liquid, so I'm administering milliliters. So I've used this. I know what I'm going to give. And now I'm going to get rid of milligrams. I'm going to use what's in my problem, 0.8 milligrams in 2 milliliters, cross off my milligrams. And now I have exactly what I need in my numerator. Now it's just math. So 4.5 times 2 is 9, and 0.8 times 1 is 0.8. That will give me 11.25. So my rounding rules, 10 and greater, I round to a whole number. So the whole number, I look, here's my whole number, right? So 2 is not 5 and up, so my answer is 11 milliliters. So I will put this in a nice little medicine cup and go up to 11 milliliters, and I will give it to my patient. Beautiful. Oh, you found your error, you divided by 8, not 0.8. And that's one of the biggest errors people make, is they actually transcribe or enter incorrectly into the calculator. So when you're blasting through these questions, the ones that you can go through fast, and you undoubtedly always have time, if you've noticed when you take your exams, go back and just make sure, spot check as many as you can before the time is up. Let me explain this one. So I don't want you to get confused because you've never seen it written as a quarter. And this was brought up yesterday, and I'm glad somebody did. I added this to just let you know that the tablet, if you were working clinically and you were about to figure out how much of a tablet to give your patient, when I wrote this quarter tab, it's because you can't see what the tablet looks like. So when I write a quarter scored, it means that the tablet you're looking at can be split into quarters. All right. So this is not part of the problem. It's just to let you know that this tablet can be split into quarters. Okay. So I'm going to pause it here, and knowing that you can split this into quarters, so this may help answer your question, Shira, and then we'll talk about the answer when you're done. Okay. So when I read this question, it's saying on hand, there's 200 microgram scored tablets. Pharmacy delivered me. That's what I have available on hand. All right. But the healthcare provider ordered 0.45 milligrams. That's my given. That's what the doctor ordered. What am I going to give? Well, it only comes in a tablet. That's what I'm going to give. I can't give anything else. That's what I have in my hand. So now I need to get rid of milligrams to get to tablet. But what's available is in micrograms. So I need a conversion. Right? So 1 milligram is 1,000 micrograms. No problem. Gets rid of my milligrams. So now I have to get rid of micrograms, and I'm going to use what's in my problem. 200 micrograms in a tablet. That gets rid of micrograms. And that leaves me with tablet. Beautiful. Now it's math. But this is where people get mixed up. 200 times 1 is 200. 0.45 times 1,000 is 450. When I divide 200 into 450, it gives me 2.25. Now I got done telling you what?
It's in tablets.
The tablet is scored in quarters, or you will see a picture on your exam. That means I will give, if my answer is 2.25, I will give 2 whole tablets, and then I will break off a quarter of another tablet. And that's what I will actually give my patient. 2 whole tablets and a quarter of a tablet. 2.25 tablets. Okay? Does that make sense now? And you found your error. You forgot the 5 at the end of a point. That's a big, right? The error. That's why I say check your math. Yes. So you can give 2.25 because your tablet can be broken into quarters because it is scored. So let's find another one. Hold on. So the question was, do I need to use a rounding rule for this one? No, because I can give a 0.25 because it came scored. So I'm going to give 2 whole tablets and a quarter of 0.25, a quarter. So on your answer sheet, you can write 2.25, or you can write 2 1/4 tablets. Because the pill that was supplied to me was scored in quarters. So that means I can break it into 4 pieces. I can break it into a half. I can break it into, I can leave it whole, but it means that I have the capability of giving a quarter if I need to. So this question is telling you that the tablet that is scored can be broken in half. It can only be broken in half. So either you give a whole or a half. That's what scored means. There's a perforation in that pill. So you will see a picture and it'll show you a pill that's in half, because when you're working, pharmacy will deliver you a pill and you will see if it can be broken in half or quarters. So you will know how you were able to give it based on what you solved. So I'm going to tell you to pause and solve this one. sure you don't make those mistakes during the, I don't want you to make those transcription mistakes when you're taking your exam, because you know what, it's not worth losing a point or 2 or 5. And that's what happens. All right, so let's do this one together. So we look for that, given that doctor's order. Well, he prescribed 62.5 micrograms, right? And what am I going to give? Well, it's supplied in a tablet, so I got to give a tablet. So let's look at our problem. There's 125 micrograms per tablet. All right. So when I cross off my unwanted, it's 62.5 times 125. And when I do the division, it'll give me 0.5 tabs. And basically that means I have a big pill sitting in my pill box, but I can snap it in half and I'm going to give the patient half of the pill. So I will accept 0.5 tablets or half a tablet. So I'm going to break my tablet in half and just give them half. Beautiful. So here is a 2-factor question. So I'm going to ask you to pause it here if you're watching the video, and everybody else, go for it. All right, let's break this one down. So a medication is ordered to be administered, 1 milligram per kilogram. They're going to get it intravenously every 12 hours. It's available 1,300 micrograms per milliliter, and the patient weighs 32 kilograms. And this question tells you what it wants. How many milliliters will you administer? So how many milliliters? So if you know me, I like to cross off what I used. So how do I get rid of kilograms? Well, I'm going to go to my problem, and the patient's weight is in kilograms. 32 kilograms. Boom, gone. Cross off my kilograms. Yay. How do I get rid of milligrams and get to milliliters? Well, I go to my problem. 1,300 micrograms per milliliter. So I need to do a conversion. So 1 milligram is 1,000 micrograms. Boom, bitty boom. How do I get rid of micrograms? Go to my problem. 1,300 micrograms per milliliter. Boom, boom, boom. Got it. Everything else is crossed off. I'm feeling good and confident. So then I do my math. So you can cross off zeros, but be careful and methodical. 1, 2, 1, 2. So this will give me 13 and 320. And when I divide, it'll give me 24.6. Greater than 10, I round to the whole number. 24 is definitely greater than 10. So 24, 6, anything 5 and up, I round up. So my answer is 25 milliliters. And that is what I will administer the patient. Beautiful. Heparin, very powerful anticoagulant. So you know the calculation for this has to be right, because they could bleed if you're wrong. Oops. All right. So let's do it. The doctor orders 1,000 units per hour. Pharmacy sends up an IV bag that's 500 milliliters and it has 10,000 units in it. But it's telling you how many milliliters an hour will the nurse set the IV pump to. So you know it's an IV pump, but it tells you milliliters an hour. The order, 1,000 units per hour. 2-factor. How do I get rid of units? 10,000 units in 500 milliliters. Boop, boop. I already have my hour, and now I have my milliliters. That wasn't too bad, right? So I can cross off zeros, which I like to do. 1, 2, 3, 4. 1, 2, 3, 4. So that will give me 50 over 1, and that will mean 50 milliliters per hour. Don't forget the hour. You got to use the proper full unit of measure, okay? Very good. Here's another question. Pause here to solve. Good job. All right, so the patient's got to get 1.5 liters of 0.9% normal saline to infuse over 10 hours. So the doctor's saying give 1.5 liters over 10 hours. This just happens to be the type of fluid. So what infusion rate should the nurse set on the IV pump? So what do I do when I look at these questions? I look for the word pump. I always look for pump So if I see there's a pump, I'm always solving milliliters an hour because it's asking me infusion rate. So I have to give 1.5 liters. So by now I am hoping you know that 1 liter is 1,000 milliliters. So 1.5 liters will be 1,500 milliliters over volume over the time, 10 hours. I have hour, I have milliliter. I'm done. I just got to divide. So you can cross off zeros and figure it out really fast. But if you were to do it the long way, you would divide 10 into 1,500, and that will give you 150 milliliters an hour. So you would literally go to the IV pump, hang the bag, and then run your tubing through the machine and press 150 and start. And that machine will automatically deliver 150 milliliters every single hour into your patient. Beautiful. Now, what about this order? Well, I wanted to go back because Moya asked a really great question. If you don't mind, I'm just gonna, before we do this one, Moya had asked, can you do it with liter? Let's say you didn't remember because you were having, test anxiety, what liters and milliliters were. So you could start with 1.5 liters, right? Over 10 hours, that's the doctor's order. He said, give 1.5 liters, 1.5 liters in 10 hours. And it says pump, so you know you have to solve for milliliters an hour, right? So I have hour, but now I have to get liters to milliliters. So this is where your conversions come in. I know 1 liter is 1,000 milliliters. That crosses off my liters. Now I have milliliters. So now I would multiply 1.5 times 1,000. It would give me 1,500. And I would still have 10 times 1 is 10. So yes, you can absolutely do it the long way if you have a brain freeze in the middle of your exam, which totally can happen. So great question, William. So let's go back to this one. So it's saying a patient is to receive 1,000 milliliters of 0.33% normal saline to infuse over 12 hours. It has a drop factor of 10 drops per milliliter. What is the drop rate? So when I look at this question, the first thing I look for is the word pump. There is no pump. If there's no pump, but there is a drop factor, I am solving for drops per minute. I got to get drops in my numerator, minute in my denominator, no matter what. My doctor's order was 1,000 milliliters over 12 hours, volume over time. So it doesn't matter where you start. How do I get hours to minute in my denominator? 1 hour is 60 minutes. Beautiful. Now I have minutes. Yay. Now how do I get rid of milliliter and get to drops? Well, I go to my problem. So I've used this, I've used this. There's 10 drops per milliliter. Oops, I did it backwards. Nobody stopped me. There are 10 drops per milliliter. That gets rid of my milliliter, and now I have drops. I look over my problem, everything I don't need is gone, and I have just what I need. Now it's just math. So you can cross off your zeros, or you can do it the long way. So 12 times 60 is 720, and 1,000 times 10 is 10,000. 720 divided in 10,000 gives me 13.88. And remember, no matter what, I cannot split a drop. So I always round drops per minute, drops to a whole number. 8 is 5 and up, so my answer is 14 drops a minute. Kiana, did you find your error?
Yes, I went instead of 12 hours, I put 10, and over there I put on less. Yeah.
Oh, see, it's usually always transcription. Ugh,
Yeah.
always gets us every time. All right, here's another, go for it. All right, let's do it. Medication is ordered to be administered 0.8 milligrams per kilogram. It is going to be given intravenously every 8 hours. It's available in 2,500 micrograms per 5 ml. The patient weighs 10 kilograms. This one tells you how many milliliters will you administer. Milliliters. 2-factor. Doesn't matter where you start. Let's get rid of kilograms. 10 kilograms over 1 gets rid of my kilograms. How do I get rid of milligrams and get to milliliters? Well, the only thing I can use in my problem is the concentration, but it's in micrograms. So 1 milligram is 1,000 micrograms. And I can get rid of micrograms by using what's in my problem. 2,500 micrograms in 5 mLs gets rid of my micrograms. So now I'm left with milliliters and nothing else. So now I can just do my math. So I can cross off a couple zeros to make it less gross. And when I do that, I get 400 over 25. And dividing 25 and 400, it will give me 16 milliliters. Judith, did you find your error?
Yeah, I forgot the conversion.
There it
Like
is.
milligrams.
That's usually what it
micrograms.
is. Yes. All right. Okay, I want you to try this one. So be annoyingly methodical like me. I promise you it will help you in the end. So I look at this question. 1 liter of D5.5 normal saline is ordered to be given over 8 hours. It gives me a drop factor of 8. What infusion rate should the nurse set on the IV pump? So what do? If it says the word pump, I do not need a drop factor because I'm always solving infusion rate and pump in milliliters an hour. If I have an IV pump, I have a machine that will deliver it, but the machine can only deliver in milliliters an hour. Okay. So if they offer you a drop factor, you cross it off. So a lot of people are like, well, why would they offer a drop factor? Well, every tubing has a drop factor in it because computers and machines fail. And if they fail, you can still give fluids, then you would use the drop factor. So that's the real reason why. Okay. So 1 liter is 1,000 milliliters. And the doctor wants it given over 8 hours. That's it. I got everything I need. I didn't need a drop factor or anything else. It's 8 divided into 100. And that will give me 125 milliliters an hour. All right. So yeah, so Courtney, you see, you were trying to use the drop factor and convert hours to minutes, and you don't have to. If you know where you're going, you know hour has to be in the denominator and milliliters in the numerator. Beautiful. All right, cool. All right, try this one. Let's do it together. All right, a patient is to receive 50 milliliters volume over 30 minutes time. I have a drop factor. It's asking me a drop rate. What is missing from this? There's no pump. There's no pump, and they offer a drop factor. So I am solving for drops per minute. I have no IV pump to use, and I have a drop factor. It is drops per minute. So volume, the doctor is ordered to receive 50 minutes, and it's an antibiotic more than likely. And it comes in a little 50 milliliter bag, and the pharmacist says you can run it over 30 minutes. So 50 milliliters over 30 minutes, beautiful. So I already have minutes, so I'm done there. So now how do I get rid of milliliters and get to drops? Well, I go to my problem. So I've used the 50, I've used the 30. Oh, all I got is 20 drops per milliliter, 20 drops per milliliter. I cross off my milliliters and now I have drops. That's it. And now it's just math, but you got to get the right math. So 50 times 20 is 1,000 and 30 times 1 is 30, and that will give me 33.33. I cannot split a drop. So 3 is not 5 and up. So I'm going to count 33 drops per minute. Beautiful. Do this one. All right, let's do it. I'm looking at these problems. I promise you, do it the annoying way that I do it. It'll help you in the end. A patient is to receive 100 milliliters IV piggyback, and they're going to infuse it over 45 minutes. The drop factor is 10. What is the flow rate the nurse will set for this IV pump? IV pump. I have a pump. I do not need the drop factor. I do not need the drop factor. If I have an IV pump, it's always going to be milliliters an hour. If they're asking me a flow rate, an infusion rate, a drop rate, a drip, it doesn't matter what they're asking. They're asking Via a pump, it's always milliliters an hour. Okay, so my volume is 100 milliliters over time, 45 minutes. So I have milliliters in my numerator, good, but I have minutes in my denominator and I need hours. So how do I change hours to minutes? 60 minutes in 1 hour. Now I have every single thing I need. That's it, I'm done. So 100 times 60 is 6,000. And 45 times 1 is 45. And when I divide, I get 133.33. 10 and up, I round to a whole number. I still follow the rounding rules with a pump. So it's greater than 10. So I'm going to round to a whole number. So my answer is 133 milliliters an hour. Okay. One more heparin unit of measure. If you forget the unit of measure or you put the wrong unit of measure, unfortunately, you will lose the entire 5 points, because in clinical practice, if you use the wrong unit of measure, you could kill a patient. All right. So here's the question. Give heparin 2,000 units per hour. That's what's ordered. That's my given, 2-factor. Pharmacy sends an IV bag with 25,000 units in it. How many milliliters an hour will the nurse set the IV pump to infuse? Well, this one was a gift. It tells you, you need milliliters an hour. So a doctor ordered 2,000 units per hour. Pharmacy sends up 25,000 units in a 500 milliliter bag. Cross off my units. Now I have milliliters, beautiful. And now I have hour, even more beautiful. So 2,000, if you want to do a long way, I'm going to cross off some zeros. 1, 2, 3, 1, 2, 3. So 500 times 2, 1,000, 25 times 1 is 25 equals 40 milliliters an hour. Beautiful. Here's another. Awesome. Good. Good, Kim. All right, you guys are getting this. I love it. All right, let's see what we got. The safe dose for a drug is 0.4 milligrams per kilogram per day. I got a 3-factor. What is the correct daily dose for a patient who weighs 105 pounds? Well, I got a 3-factor, 0.4 milligrams per kilogram per day. I cross off what I'm using because it's going to get crazy and you know it. Excellent. What am I solving for? Daily dose. Well, the only dose available is a milligram, and they need a daily dose. I have the word day. I have milligram. All I have to do is get rid of kilogram, but the weight is in pounds. So 1 kilogram is 2.2 pounds, and the patient weighs 105 pounds. Put that over 1, keeps me focused. Life is good. Now I just do math, and it's 42 over 2.2, and when I divide, it'll give me 19.09. Anything 10 and up, I round to the whole number. That is not 5 and up, so I'm going to give 19 milligrams a day in total. Beautiful. Hold on one second. Let's do this one. All right, go ahead and do this one. All right. No tricks here. You're just following the same thing. These are how orders are written. All right. So keep yourself focused. If you follow the same process and steps, all right, it's like that muscle memory. All right. The doctor orders 4.5 micrograms per kilogram a day. It is a 3-factor. The patient weighs 35 pounds, daily dose. I don't have much to work with, but I know what to do. 4.5 micrograms per kilogram per day. So I need a daily dose. The only dose available is micrograms per day. Days in my denominator, micrograms in my numerator. Got to get rid of kilograms, not a problem. 1 kilogram is 2.2 pounds because the weight is in pounds. 35 pounds over 1. Oops, over 1. And now it's just math. So when I do the math, it'll give me 157.5. Remember, never round to the end of all problems. That'll be 71.5. Anything greater than 10, I round to the whole number. 5 and up, I round up. So it is 72 micrograms every day. Beautiful. Here is the difference. So I'm gonna tell you to pause if you're watching the video and try to solve this. All right, the doctor's ordered 6 milligrams a kilogram a day, but it's gonna get 2 divided doses. The patient weighs 68 kilograms. It comes in grams and milliliters, and you have to figure out what you're gonna give for one of those 2 doses. So 6 milligrams per kilogram per day. I need to know what am I going to give per dose, right? And it comes in a liquid per dose. It's available in milliliters, but they want to know what I'm going to give the dose. What am I going to actually bring to that patient and give for that 6 a.m. dose? So every day, how many doses? 2 doses. Every day, 2 doses. I got to get rid of day and get doses. Now, how do I get rid of kilogram? I use the patient's weight, 68 kilogram over 1. That gets rid of kilogram. So now I have to get milligram gone and milliliter added, but it's only available in grams. So this is why I like to cross off what I've used. All right. So I have to do a conversion. 1 milligram. I'm sorry. Gosh, 1 gram is 1,000 milligrams. That gets rid of my milligrams. And now I can say 1 gram is in 5 milliliters. That gets rid of my grams. So when I look at my problem, everything else is crossed off and I only have what I need. So now it's math. So when I do the math, it's 2040 over 2000. And when I divide 2000 to 2040, I get 1.02. Now 1 to 10, I round to the tenths. 5 and up, I round up. This is not up. So if you did it like this, you're thinking, yeah, it's 1. But what's the rules with the zeros? You can't have a trailing 0 because we may mistake it for 10 and not 1. So the answer is 1 milliliter per dose. Okay, let's do another. Let's do it. The doctor ordered 0.3 grams per kilogram per day. We're going to give it in 4 divided doses. He's going to get it 4 times a day. It's available in milligrams per milliliter, 750 milligrams per 1 ml. And they want to know how many milliliters you're going to give it 10. So that's a specific dose. So you want milliliters in the dose. And it's a 3-factor, 0.3 grams per kilogram per day. Use that. I know I'm giving milliliters. So how do I get rid of the word day and get the word dose? Well, every day the patient's going to get 4 doses. Boom, now I have dose. Yay. How do I get rid of kilogram? I use the patient's weight. 85 kilograms. Boom, boom, yay. I've used that. Now, how do I get rid of grams and get to milliliters? Well, the concentration is available in milligrams, so I need a conversion. 1 gram is 1,000 milligrams. And there's 750 milligrams for every 1 milliliter of medicine. Beautiful. I got rid of everything I don't need. I have what I want. And then it's gross math. So we're going to do the long math over 3,000. And that will give me 8.5 milliliters. 1 to 10, I round to the tenths. And that's for every dose I give. Beautiful. All right, go ahead and try this one. Let's do it. The order is 100 milligrams per kilogram per day in 3 divided doses. That means every day they're going to get 3 doses, right? That's what that means. Patient weighs 108 kilograms and it's available in grams per 10 ml. They want to know what dose will you give at 2,200, right? So 100 milligrams per kilogram per day. Every day there's 3 doses. The patient weighs 108 kilograms. So I've used this, I've used this, I've used this. So how do I get rid of milligrams? And I go to my problem and it's only available in grams. So, 1 gram is 1,000 milligrams. How do I get rid of gram? I go to my problem. There's 4 grams in 10 mLs. Boom, boom. Milliliters, doses. Now it's just math. It's gross math, but it's math. When I multiply all this, I get 108,000 over 12,000. And when I divide, it'll give me 9 milliliters a dose. So at 2,200, when I go in to pass their medication, I'm going to make sure they receive 9 milliliters. All right. Here's another type of problem you'll come across. Give it a try before it's midnight. All right. The doctor ordered 60 micrograms per kilogram per minute. The IV bag is labeled 1,200 milligrams at 1,000 milliliters. The patient weighs 105 pounds. The drop factor is 20. Calculate the infusion rate for the IV pump. So what is the rule? If it says there's a pump, we do not need the drop factor. Cross it off. Get it out of your sight, whatever it takes. If it's a pump and they want infusion rate, you are solving milliliters an hour. Okay, so we start with 60 micrograms per kilogram per minute. Gone, used it. So wherever you want to start is fine by me. Let's get rid of minute because I need hour. 60 minutes in 1 hour. Excellent. Done. How do I get rid of kilogram? Because I do not need kilogram in my denominator. I go to my problem. My problem, the patient's weight is in pounds, so I know I need a conversion. 1 kilogram is 2.2 pounds. I got rid of kilogram, but now I got to get rid of pounds. I use the patient's weight, 105 pounds. That gets rid of pounds. Boom, done. So now I have to get rid of micrograms, and I have to get to milliliters. Well, the only thing I haven't used is this concentration. But again, it is in milligrams, so I have micrograms. I have a conversion. 1 milligram is 1,000 micrograms. Got rid of my micrograms. Now I have to get rid of milligrams. Here I can use my concentration. 1,200 milligrams in 1,000 milliliters. I get rid of my milligrams, and that is it. I look over my problem. Everything I don't need is gone, and the only things I do need, milliliters in the numerator, hours in the denominator, and I'm good. So now it's just math. So it's really long, gross math. You can cross off your zeros. Your calculators may not get to that high, so I encourage crossing off zeros. Just be careful when you do it, okay? You can cross off it into, if 1,000 and 1,000 are equal, you can cross off that. But I encourage crossing off zeros. You can cross off zeros, 1, 2, 1, 2, and then it's just math. But basically, when you do solve, you will get 143.18. Anything over 10. So that this goes back to Rosa's question. When we use IV pumps, we can use decimals. Only IV pumps can use decimal points, but we still follow the rounding rules when we're going to use the decimal point. So our rounding rules say 10 and up, we round to the whole number. So this answer is 143 milliliters an hour, and that's what I will plug into my pump. So Rosa also asked, but what if the pump solves to be 10.5? We follow our rounding rules. 10.5, we would set the pump to 11 milliliters an hour. What if the answer came out to 10.2? Our rounding rule still says we follow 10 and up, we round to the whole number. 10.2, we don't round up, so it'll be 10 milliliters an hour. What if we were solving for a pump and the answer was 9.86? We would set the pump at 9.9 milliliters an hour, because between 1 and 10, we round to the tenths, 5 and up, we round up. Does that help, Rosa? Okay, if it does, I'm glad. What if we got an answer that it said the pump said 5.555? So we would round 1 to 10, 5 and up. We would set the pump to 5.6 milliliters an hour. So hopefully that helps you. All right, let's do this one. Alrighty, so same steps, same process. What does the doctor order? That's my given. I got a weight in pounds. I got a concentration from the pharmacy, a 500 milliliter bag of fluid. I got a drop factor, and it says infusion rate, and it says IV pump. I'm looking at it. If it says IV pump, it has a pump. I do not need the drop factor because it's asking me a fusion rate. So I'm crossing it off. So I know I'm solving milliliters an hour. Start with 6 micrograms per kilogram per minute. Boom, done. Doesn't matter what I want to get rid of first. Let's get rid of kilograms. The weight is in pounds, so I need 1 kilogram is 2.2 pounds. Patient weighs 200 pounds. Boom, boom, boom. I'm crossing off what I'm using. How do I change minute to hour? I know that one. 1 hour is 60 minutes. Oops, crossed off the wrong one by accident. Sorry. 1 hour is 60 minutes. So now I've got hour. Yay. So now I have to get rid of micrograms, but unfortunately it's in milligrams. So 1 milligram is 1,000 micrograms. And it's available in 750 milligrams for every 500 milliliter bag. So that is my setup. It looks good. I can cross off some zeros. Sure. 1, 2, 3. Let's say, where am I? I'm going to do 1, 2, 3. So you can cross off zeros wherever you want to get the numbers smaller so you can work easily with your calculators, because some of your calculators get the E error message. But anyway, when I do the math, it's like 3,600 after I cross off my zeros over 165. That will give me 21.81. Anything over 10, we follow the rounding rules. 10 and up, I round to the whole number. So 8 is greater than 5. So it is 22 milliliters an hour. Beautiful. All right, let's get to some. So Judith had a question about if your answer is less than 1. So let me review a little bit about less than 1. So if you have an answer that is less than 1, let's say you get an answer on your calculator that says point.
Can you move that back down for a minute, please? Just for a quick second. Thank you.
Sure. You want me to talk about the 1 thing too? All right. So when you have an answer, all right, let's start with less than 1. Okay. So if you get an answer on your calculator that says 0.00, oh, shoot. You get an answer that says 0.00852. That's your answer, right? So how do you round that properly? Well, when you have an answer less than 1, we round to the hundredths, right? So normally the hundredths are 2 spots after the decimal. But are zeros significant numbers? No. So that's the problem. We have to round to 2 significant numbers. The next significant numbers are 8 and 5. Zeros are not a significant number. You can't say the answer is 0.00 or 0.01. That's not, you have to find significant numbers. So what is the answer to this? You would write 0.0085. If your calculator gave, like Judith's example, gave you an answer of 0.002, well, if that's all that the math solves to, then the answer is 0.0002. Because remember, we can't forget the 0 before the decimal. So now Claudia asked, what about the 1.0 thing? Well, what if you get an answer on your calculator that says 1.04? If we were to follow the rounding rules, 1 to 10, we round to the tenths. 5 and up, we round up, but this is not up. So we don't round to 1.1. We would round to 1.0. But what are our rules about zeros? we never leave a trailing zero after the decimal. So that's why this answer would be 1. Because clinically in practice, if somebody wrote 1.0 like that, I may come to work and say, oh, the patient's going to get 10 milliliters. Because maybe I didn't notice that decimal. So it's called never leave a trailing zero. So the answer would be 1. Yes, so 1.05 would be 1 to 10, I round to the tenths, 5 and up, I round up, it would be 1.1. So you got it now? Oh, yeah.
Wait, Professor, do that thing that you did yesterday where you put the 0.0091991 repeating.
That was my question that I wanted to ask. Yes, that.
The 00, oh, what was it again? I'm trying to remember. It
was
was 0.09092.
Ah,
It was
yes.
like it's repeating. It was repeating.
Oh, okay,
It was,
so yeah, it was
like
probably
it was
0.0909.
There was 2 zeros, so it was point
Oh,
zero
okay.
90
Point
9090.
0090 that way?
Yeah.
Okay, so again, if your calculator gives you that, my hundredths, I can't do zeros. So I go to the next significant numbers, the next 2. But when I look to the, I always look to the right. So if I look to the right here, I would get, if I did it this way, I would get 0, 0, 1, right? But I don't have 2 significant numbers. So then I keep going. So then I look here and I look to the right. I would have 2 significant numbers because then I would have 9, 1. Because I would go 9 up. So my answer for this would be 0.0091. Basically, you can't have zeros as a significant number. But I won't torture you that much on an exam. But I'm showing you the rounding rules. Oops. So you always go to the number to the right. So the 4 or 5 are not, what do you mean the 4 or 5 are not significant? Are you talking about the 1.04, Shira? Oh, okay. No, yeah. When we have numbers that fall between the number 1 and number 10, we round to the tenths. The tenths is one spot next to, the tenths is this. So I look to the number to the right. And if it's not greater than, if it's not 5 and up, I can't round up. I can't round up this number. So when I look at this one, I look to the right. I can round up a 5. That's why it's 1.1. But on this one, I don't round up for 4. So that's 1.0, but I'm not allowed to write 1.0 because of the trailing zero rules. Okay. All right. I want to be able to get to this time. So let's do it. Solve this problem. All right. So when you see these kind of questions, you've got to really break it down and look at what they're asking, okay? So they're saying that an IV of 700 milliliters is already going, it's already infusing at 10 drops a minute. The drop factor is 8, which means it's getting 8 drops per every milliliter. At 10 a.m., you, the nurse, you walk into the room and that IV only has 400 milliliters left in the bag. What time will the IV finish? All right, so you've got to really look at what you've got to read your questions. And basically the long and the short of this problem is you always start with what's left in the bag. It's just telling you that if originally there was 700 milliliters somewhere being hung by a nurse. And that's great information because that means 300 milliliters have already gone in. That's wonderful when you're practicing as a nurse, but this question is asking you something specific. So I want you to think about it. Professor K walks into the patient's room at 10 a.m. And when she looks at that IV bag, there's only 400 milliliters in it. What time will that bag finish? And I need to know what time because I have to go back in with a brand new IV bag so it doesn't run dry. So I'm starting with 400 milliliters because that's what I assessed. There was 400 milliliters in that bag. So I'm solving for time, military time. So I'm solving for hours. So I've used 400. I don't care about the 700. I wasn't there when that happened, maybe. I don't know. But when I walked in the room at 10, there was 400. That's what I care about, left in the bag. So how do I get rid of milliliters? Because all I need is hours in my numerator. I look to my problem. Well, I got 8 drops in a milliliter. I got 10 drops going every minute. Well, I can use my 8 drops to get rid of milliliters. So there's 8 drops per milliliter. That gets rid of my milliliters. How do I get rid of drops? I look to my problem. 10 drops per minute. I've used that. Now I have minute, have to get the hour. I know that conversion. Every hour, there's 60 minutes. Beautiful. Now I have everything in my problem to solve. So when I do the long math, and please do not round these problems until the very end, and I'll talk about it while I'm doing it. When I multiply across the top, I get 3,200 over 600. And when I divide 600 into 3,200, it will give me 5.3333333. It'll keep going. Now, this is the error that everybody keeps making. You guys end up rounding it to 5.3. That's wrong. All right. What does the 5 represent before the decimal? That's your hours, 5 hours. 0.333333 represents minutes, but I don't know any minutes that talks about 0.33333. So I have to multiply 0.33333 times 60. And I recommend going at least 6 out, at least 3 numbers out. So 0.33333 times 60 is 19.99. So if this represents minutes, now I'm going to round this to 20 minutes. So 5 hours and 20 minutes. So it's saying that it will take 400 milliliters, 5 hours and 20 minutes to infuse and become empty. But the question is not asking me that. It's not asking me how long. It's asking me the exact time. So if I walked in at 10 a.m. and it takes 5 hours and 20 minutes to infuse, I'm going to walk back in at 15:20 with a brand new IV bag to hang on my onto my patient's pump or gravity, I'm sorry, to hang. So a lot of times people get it wrong because they put 5 hours and 20 minutes. Well, I didn't ask you how long. I asked you what time. And if I walked in at 10 a.m. and it takes 5 hours and 20 minutes, I got to walk back in at 15:20 with a brand new IV. Now, make sure you write it like this, 15:20. It is not 15:20 like that. It's military time. All right. So don't forget that. That's very, very important. So let's do another. 5 p.m. at night. Let's do it. All right. Again, they got an IV. There's 1,000 milliliters. It's been running at 40 drops a minute. They have a drop factor of the tubing of 20 drops a milliliter. At 1400, Professor K walks in the room and there's only 500 milliliters left in the bag. What time will it finish? Well, I only care about what I'm looking at, and that's 500 milliliters. Used it. This is nice to know. And I'm solving for hours. So how do I get rid of milliliters? I go to my problem. The only thing with milliliters in it is my drop factor. So 20 drops per milliliter. Boomity boom. Yay. How do I get rid of drops? The only thing here that has drops in it is my drop rate. So 40 drops per minute. Yay. That's gone. How do I get minutes to hours? 1 hour is 60 minutes. Yay. So now it's just math. So when I do the math, it will give me, what is it? 10,000. over 2,400, and 2,400 divided into 10,000 will give me 4.166666666. So keep going. Go out at least 6 numbers. 1, 2, 3, 4, 5, 6. That's what I do. All right. So I say 4 hours, and 0.16666 times 60 is 9.9999. And this is minutes. So I'm going to round it to 10. 9 and up, I round up. So that's 10. So 4 hours and 10 minutes, but it's asking the exact time. So Professor K walked in at 1400. It takes 4 hours and 10 minutes. So the answer is 1810. I'm going to walk back in at 1810, which is what time, by the way?
It's 6:10.
6:10.
Yeah, 6:10 p.m. So I'm working day shifts. I'm out of there at 7. All right. So 1810, I'm walking in with a brand new IV. Beautiful. So we have covered everything you can anticipate to come across. So again, I'm going to ask Zoom to save this recording. And if they save the recording, I will post it. And I will also post that YouTube link just in case Brightspace deletes the video because they are large videos. All right. And this way you can just go to the link and you can watch this video and yesterday's video. And honestly, when you're doing it, just pause the video and keep doing it. Even if you've done the problems before, just keep doing the problems, keep practicing, be completely methodical about it. It will really, really help you in the end. All right.
Thank you, Professor K.
You're very welcome. And I
Thank
wish
you.
you all luck on your exam coming up Monday, Tuesday, Wednesday, Thursday.
Thank you, Professor.
You're welcome. Bye-bye.
Yeah, bye-bye.